What if I told you that everything you've ever seen in the universe is the exception, not the rule? Every star in the night sky, every galaxy captured by powerful telescopes, every planet, moon, and nebula combined make up only a tiny fraction of reality. The truth is far stranger, and far more unsettling. The universe isn't filled with stars, it's filled with emptiness. Vast regions of absolute nothingness stretch across unimaginable distances, separating islands of light in an endless cosmic ocean. And once you truly understand just how empty the universe is, you'll never look at the night sky the same way again. Most images of the universe show countless stars, galaxies, and glowing clouds of gas, creating the impression that space is full of objects. However, this picture is misleading. The reality is that the universe is dominated by emptiness. Everything we can see, stars, planets, galaxies, and even ourselves, accounts for less than 5% of the total universe. The remaining 95% consists of mysterious dark matter and dark energy, substances we cannot directly observe. Even visible matter is not spread evenly, it gathers into clusters and filaments, leaving behind enormous regions of near-total emptiness. The stars we admire in the night sky are not the rule of the cosmos, they are rare exceptions in a universe defined by vast voids. To understand cosmic emptiness, we must begin with our own solar system. Although it may seem compact in diagrams, the actual distances are staggering. Pluto, once considered the ninth planet, orbits about 6 billion kilometers from the Sun, and sunlight takes more than 5 hours to reach it. NASA's New Horizons spacecraft, the fastest probe ever launched, still required 9 years to reach Pluto. Yet Pluto is not the edge of our solar system. Beyond it lies the Oort cloud, a vast shell of icy objects that may extend nearly a light-year from the Sun. Humanity has never directly observed this region, and even Voyager 1, traveling for nearly 50 years, would need tens of thousands of years to cross it completely. Leaving the solar system behind reveals an even more astonishing reality. The closest star to our Sun, Proxima Centauri, is located 4.24 light-years away. A light-year is the distance light travels in a full year, about 9.5 trillion kilometers. While light can reach Proxima in just over 4 years, our fastest spacecraft would require around 70,000 years to make the journey. Proxima Centauri is part of a 3-star system known as Alpha Centauri and hosts a planet called Proxima b, which lies within the habitable zone. However, intense radiation from the star likely makes life difficult there. Even our nearest stellar neighbor remains unimaginably distant, highlighting how isolated stars truly are. The Milky Way contains between 200 and 400 billion stars, yet it is far emptier than most people imagine. The average distance between stars in our region of the galaxy is several light-years. This means that even when galaxies collide, actual star collisions are extremely rare. The Milky Way itself is a vast spiral galaxy stretching roughly 100,000 light-years across. At its center lies Sagittarius A*, a supermassive black hole with the mass of 4 million suns. Our solar system resides about 26,000 light-years from this center, occupying an ordinary location within one of the galaxy's spiral arms. Despite containing hundreds of billions of stars, the Milky Way remains mostly empty space. Many people assume that future technology will eventually overcome the speed of light, allowing humanity to travel freely among the stars. However, according to our current understanding of physics, the speed of light is not merely a technological barrier, it is a fundamental limit of the universe. As an object approaches light speed, it requires increasingly large amounts of energy to continue accelerating. Reaching the speed of light would require infinite energy, making it impossible for anything with mass. Even if we could travel at light speed, crossing the Milky Way would still take 100,000 years. The universe is not just large, it is structured in a way that naturally separates everything within it. Our nearest major galactic neighbor is the Andromeda Galaxy, located approximately 2.5 million light-years away. Under dark skies, it can be seen with the naked eye as a faint patch of light. However, the light reaching our eyes today began its journey long before modern humans existed. Andromeda and the Milky Way are part of a small collection of galaxies known as the Local Group. Beyond this group lies even greater emptiness. The distances between galaxies dwarf the distances between stars, creating vast intergalactic regions where matter is incredibly scarce. In some places, there may be only a single atom per cubic meter of space. When astronomers observe the universe on its largest scales, they discover that galaxies are not randomly distributed. Instead, they form a gigantic structure known as the cosmic web. Galaxies gather into clusters, clusters combine into superclusters, and superclusters connect through enormous filaments stretching across hundreds of millions of light-years. Our galaxy belongs to a supercluster called Laniakea, which contains around 100,000 galaxies. These structures resemble a vast network of threads spanning the observable universe. Yet even within this immense web, most of the cosmos consists of empty regions between the filaments. Between the filaments of the cosmic web lie the largest empty regions in existence, cosmic voids. One famous example is the Boötes void, a region roughly 330 million light-years across. Based on average galaxy density, astronomers expected thousands of galaxies there but found only a handful. These voids form because gravity pulls matter toward denser regions, leaving behind expanding pockets of emptiness. Although not completely empty, they contain far fewer galaxies than expected. Life inside such a void would experience a very different cosmic environment, isolated from the bustling regions where galaxies are more common. One of the strangest facts about astronomy is that every observation is also a journey into the past. Because light takes time to travel, we never see distant objects as they are today. We see them as they were when their light began its journey. The James Webb Space Telescope has observed galaxies more than 13 billion light-years away, revealing the universe as it existed shortly after the Big Bang. Some of these galaxies may have changed dramatically or disappeared entirely since then. Every star, galaxy, and nebula we observe is a snapshot from a different moment in cosmic history. If we look far enough into space, we eventually reach the cosmic microwave background, the oldest light we can observe. This radiation comes from a time when the universe was only about 380,000 years old. Before this period, the universe was so hot and dense that light could not travel freely. The cosmic microwave background therefore acts as a boundary, marking the limit of what we can directly observe. Beyond it lies a region forever hidden from our view, not because it is dark, but because the laws of physics prevent us from seeing further back in time. The universe is not static, it is constantly expanding. Galaxies are moving away from each other because space itself is stretching. The farther a galaxy is from us, the faster it appears to recede. Some galaxies are already moving away so quickly that light emitted by them today will never reach Earth. This expansion is accelerating due to a mysterious force known as dark energy. Over billions and trillions of years, more and more galaxies will disappear beyond our observable horizon, permanently cut off from our view. In the far future, the universe will become a much lonelier place. As cosmic expansion continues, every galaxy outside our local group will eventually vanish beyond the observable horizon. Future civilizations may look into the sky and see only a single merged galaxy, with no evidence that countless others once existed. They would have no way of discovering the true history of the cosmos. The vast interconnected universe we observe today would appear small, isolated, and alone. The universe is often described as a place filled with wonders, and it certainly is. Yet its most important characteristic is not the abundance of stars or galaxies but the immense emptiness that separates them. We live on a small planet orbiting an ordinary star within one galaxy among trillions. The stars, galaxies, and cosmic structures that inspire us are merely tiny islands of matter floating in an ocean of almost unimaginable nothingness. And perhaps that is what makes our existence so remarkable. In a universe defined by separation and emptiness, life emerged, consciousness appeared, and for a brief moment, the cosmos became aware of itself.